Okay, on this problem, the denominator is a binomial. It's a 1 plus the square root of 5. You can't just multiply by the square root of 5, which is what a lot of people do, and I'll show you what happens if you do that. Because if you take 5 times a binomial, you have to distribute it. I'm sorry, square root of 5. And when you take the square root of 5 times 1, that's still a square root of 5. The square root of 5 times the square root of 5, that just becomes a 5, but now you've created a radical over here. So you're not getting anywhere. So that doesn't work. So let me erase all this lovely green. So what you have to do is take the 1 plus the square root of 5 and you multiply it times a 1 minus the square root of 5. These are what they call binomial conjugates. Binomial conjugates. My handwriting's not the greatest, I'm sorry. They're almost identical, except that one of them has a plus sign and the other one has a minus sign. And what happens is whenever you multiply two binomials together, you use something called the FOIL method. First, outside, inside, lasts. But when you multiply conjugates, when you go to do outsides and insides, they're actually identical, except one's a plus and the other one's a minus, and so they cancel each other out. And that gets rid of the inner radical. So let me just show you. When you're doing the FOIL method, you multiply first times first. 1 times 1 is 1. Then you do the outsides. 1 times a minus square root of 5 would be a negative 1 square root of 5. Then you do the insides. A square root of 5 times a 1 would be a positive 1 times the square root of 5. And then last times last is a positive square root of 5 times a negative square root of 5. It's a positive times a negative, which is a negative. And the square root of 5 times the square root of 5 is the square root of 25, but the square root of 25 is just 5. And then what happens is a negative 1 square roots of 5 and a positive 1 square roots of 5 cancel each other out. And so all you're left with is the 1 at this end and a minus 5 at that end. And that makes my denominator 1 minus 5 a negative 4. But keep in mind, that stuff that I'm doing right there is just rationalizing the denominator, which means you got to get rid of the radical in the denominator. But remember, we're in fraction land, and whatever you do to the denominator, you must also do to the numerator. So I have to multiply the same damn thing up here. Now up there, since it's a 4, which is a monomial, times a 1 minus square root of 5, which is a binomial, we do have to use the distributive property. Let me grab a different color here. So I'm going to take 4 times 1, which is 4, and 4 times the negative square root of 5, that's going to make it a minus 4 square roots of 5. And I have successfully rationalized my denominator. There's no more radical down there. However, we are still in fraction land. And there's another rule in fraction land that says all answers should be in simplified form. And the only way you do that is by canceling out common factors. Like if you had the fraction 4 over 6, 4 is a 2 times 2, and 6 is a 2 times 3. And then this 2 cancels that 2, so you're just left with 2 over 3. And of course, most teachers, they make students practice factorization, like 2 times 2 and 2 times 3. But after a while, you learn, don't you just divide out a common factor? Well, yes, you do. 4 divided by 2 is 2. 6 divided by 2 is the 3. But that works when you have just, these are just numbers. Over here, I have a binomial. I have this subtraction between those two. So to get a common factor, I actually have to factor. All right. Now the denominator, I'm not messing with that. But my numerator, let me get another color here. How about orange? Nah, how about this color? Okay. When you're looking at this 4 and this 4 square roots of 5, those are two separate terms. You have to ask yourself, what do they have in common? A 4. Just like when I'm looking at the 4 and the 6 here, yeah, I know they're a numerator and a denominator, but when you're simplifying this mess over here, you're looking what's common to both the numerator and the denominator. When you're factoring out a greatest common factor from a binomial here, you have to look at every single term and ask, what does every single term have in common? And they all have a 4 in common. So I'm going to pull that 4 out. And when I do this, which is actually called factoring out a greatest common factor, I like to call it undistributing. I'm undistributing, which is basically, if you look back up here, we distributed this 4. We went 4 times 1 and 4 times -5. I'm going to factor that back, or negative square root of 5. I'm going to factor that back out. When you take 4 and divide it out of this 4, you're left with a 1. When you take 4 and divide it out of the 4 square roots of 5, you're left with the minus square root of 5. Ooh, it looks just like this now. I'm back to this again. I think they did this on purpose with that 1 because it doesn't always match what you started with. But I think they're trying to show you that you're just pulling the 4 back out. And let me rewrite this. So I have a 4 and a 1 minus the square root of 5 all over a -4. And I have, let me go back to the blue color. This is multiplication right here. So when I was doing this right here, it was a 4 and a 6. I can do the same thing right here with this 4 over -4 because they're separated by this multiplication on these parentheses. So I can say, if I take 4 and divide out the 4, I'll be left with a 1. And if I take the -4 and divide it by a 4, I'm left with a -1. And I'm running out of room here. Let me erase this. Sorry. Follow me. Come on, up here. So what you're left with is 1 times 1 minus the square root of 5 over a -1. And of course, 1, this 1 right here times all this stuff just leaves me with all that stuff. I'm just left with 1 minus the square root of 5, and I can drop the parentheses. However, it's still over a -1. So you're literally going to distribute the division. I'm going to take this 1 right here and divide -1 into that. 1 divided by -1 is a -1. And then I'm going to take my negative invisible 1, there's technically a -1 right here, square root of 5, and divide -1 into that. And a negative divided by a negative makes this a positive 1 square root of 5. But that 1 in front of the square root of 5 is not needed. So they'll just leave it as a -1 plus the square root of 5. Now, you could write it the square root of 5 minus 1, but you have to make damn sure that this radical symbol is cut off on the 5. A lot of times when people write this, they'll go square root of 5 and they'll put like the -1 like right there. And it almost looks like the square root is over both the 5 and the -1. And if it were, that'd be a totally different answer. Because 5 minus 1 would be 4 and the square root of 4 would be 2. That's wrong. You've got to make sure that this is cut off. So to avoid that problem,